This is LSAT PrepTest 152, Section 3, Passage 4. It is a cosmology passage about the Big Bang, entropy, and the multiverse. It is medium difficulty, and the science might sound scary, but don't let it fool you. The structure here is straightforward. The trick is that the science makes you read slowly when you should be reading for structure. Now, this is an explanation passage. It sets up a mystery, then gives you one team's answer. Carroll and Shen think the Big Bang was not a one-off miracle. It was a natural, repeatable event inside a much bigger multiverse, and that is the main point. Everything in this passage either builds up to that claim or supports it. Now, the most important paragraph is paragraph 4. That's when Carroll and Shen actually make their move. If you skim it, you're going to misunderstand their whole argument, but I'm going to come back to that. Paragraph 1 is background you probably already know. The universe started tiny, hot, and dense. Inflation happened. Things expanded and cooled. There is zero argument here. The passage is just getting you oriented. You want to read it once and keep moving. Don't let it eat up your time. Then paragraph 2 drops in Carroll and Shen. Their big claim lands right away. The Big Bang wasn't unique. It happens repeatedly across an enormous timescale. And our universe is not the whole show. It's sitting inside a larger structure, a multiverse. The passage uses the phrase cosmic bubble to describe our universe. And that is a great image to hold on to. We're one bubble in a much bigger thing. Now, the move this paragraph makes is a scale shift. You go from thinking about our universe to thinking about something way larger. And if you miss that shift, the rest of the passage is not going to track. Now, paragraph 3 is long. It looks important, but it's not, at least not in the way you'd expect. This whole paragraph is a science lesson about entropy. Entropy means disorder. The second law of thermodynamics says disorder increases over time because there are more ways for things to be messy than to be neat. The passage gives you a room analogy. If you move stuff around randomly, the room gets messier, not tidier. That's the whole idea. You don't need the details of that analogy. You just need to have the principle. Systems naturally drift toward disorder. So you want to treat this paragraph like a textbook page the author stuck in to make sure you're ready for what comes next. You want to read for the concept here and skip the math. Now for paragraph 4, you want to slow way down because here is the mystery. If things naturally become more disordered, then the universe should have started in a high entropy state with everything spread out, cold, and random. But it didn't. It started in a low entropy state, which was hot and dense and incredibly ordered. So that doesn't match what you would expect. And here's where Carroll and Shen do something clever. They flip it around. They say the most common initial condition actually looks like cold, empty space, not some perfectly arranged, hot, dense point. And so the Big Bang didn't need a special setup. It came from the most ordinary starting point imaginable. And that flip is the entire passage. If you miss it, you're going to think Carroll and Shen are saying the Big Bang was some weird exception, but they're arguing the exact opposite. Then paragraph 5 gives you the mechanism. Recent research has shown empty space has tiny energy fluctuations at the subatomic level. Two other physicists, Garriga and Vilenkin, proposed that these fluctuations can spark their own Big Bangs in tiny pockets. Carroll and Shen take that idea and apply it. They say our universe is one of those fluctuations popping up inside a high entropy multiverse. So this paragraph answers the how question. It's supporting evidence. You want to read it carefully enough to get the mechanism, but you don't want to memorize the names. Then paragraph 6 is the landing. If you look at it alone, our universe seems wildly improbable. But inside the multiverse, it's not improbable at all. And that last line is supposed to hit you hard, saying our universe probably is not even a unique event. That is Carroll and Shen's whole point in one sentence. So the passage ends where it wants you to end up. Now the key move here is in paragraph 4. The standard expectation says a random starting point should be disordered. Carroll and Shen say yes, and that disordered starting point is exactly what produces a Big Bang through fluctuations. They turned the mystery into the explanation. And the test writers are going to build the hardest questions around whether you caught that reversal. Now, there is a pattern running through this passage that's worth naming. It is a zoom out. Paragraph 1 gives you our universe. Paragraph 2 pulls back to the multiverse. Paragraph 3 gives you the physics. Paragraph 4 reframes the problem. Paragraphs 5 and 6 put it all together at the largest scale. Every step widens the lens. If you feel the passage getting bigger as you read, you're tracking it right. Now, the author presents Carroll and Shen's view favorably. There is no pushback anywhere, no competing theory, no some critics say. The author is walking you through this explanation because they find it convincing. The trap is thinking this passage is about how mysterious the Big Bang is, but it's not. It's about how the Big Bang stops being mysterious once you zoom out far enough. If you pick an answer that treats the Big Bang as a deep, unsolved puzzle, you've fallen for what paragraph 3 set up, before paragraph 4 knocked it down. Before you hit the questions, you want to make sure you can answer these three things. First, what is the difference between what you'd expect from a random starting point and what our universe actually looked like? Second, why does Carroll and Shen's argument need the multiverse? What problem does the multiverse solve for them? And third, why does the passage spend all of paragraph 3 on entropy before the real argument even starts?